Hello everybody, I will start my today another live coding session. So today, or I should say yesterday, I solved this question, maximum subarray, with bottom-up DP. Yeah, and the time complexity was O of n. And you can see here that there is a follow-up. If you have figured out the O of n solution, try coding another solution using divide and conquer approach, which is more subtle. Yeah, so I will try this today. So that being said, okay. Oh, so yeah, before diving into that approach, I will quickly review the question statement. And so in this question, I'm given one integer array nums, and I will find the subarray with the largest sum, and I will return that sum. So the input should be the integer array nums, and the output should be the integer, which is the largest maximum sub. And one more thing I had to take care is that the empty array is not allowed as the subarray in this question. So that's one thing I have to take care. Okay, that being said, I will try to solve this question with divide and conquer. So let's say, for example, our array is like this. In this case, I'm pretty sure that the biggest subarray should be this. In this case, there is -1, -2, and including those will decrease the number of, the subarray sum. But even with including that, there is 4 or 6, which is larger than -3. So it worth including -1, -2 to get 4 and 6. And for -2 and -1, as the head and tail, definitely we shouldn't include it. So in this way, I get the maximum sum 7. So this is it. Okay, and today I will try to solve this question with divide and conquer. Yeah, and when I think of the divide and conquer approach, what comes to in my mind is that I will divide the subarray into 2 for each step, and I will do it recursively like this. Okay, and now what I can say is, for example, and I will think of it in bottom up way. So firstly, when there is only one element in the subarray, what I can do is just use it. Again, I would say I'm not allowed to use an empty array as the subarray, so I have to choose at least one element. Yeah. So here, the result, which is the largest maximum sum, should be -4, 4, and -2, 6 in these cases. And then I will think of this, range. What's the maximum subarray in this range? -2 and 4. And again, I would say for this range and this range in line 17, I know the maximum subarray, but also obviously I can return any information I want from for that range. I mean, in the sub range, like sum or maximum, minimum, or prefix sum, say suffix sum, or something like that. Every information I can return. Yeah. And my task is to somehow build the maximum subarray sum of this range from this and this. So I somehow would like to get the maximum subarray of range X from the statistics of Y and Z. If it's possible, then I just have to return that to the parent and parent and parent, and finally in the caller, of this, I get the maximum subarray sum in the whole range. Okay, so what do I need to get the maximum subarray sum of range X from statistics of Y and that of Z? Maximum subarray sum. So let's think where in Y and where in Z there is maximum subarray sum. So let's assume, say, in this case, maximum subarray sum, it's obviously the whole range for these chars. So the maximum subarray sum should be the sum of them. So I will think how I can build the subarray sum when I concatenate this and this. One approach is that this becomes the maximum subarray sum, or let's assume so let's assume this is the maximum subarray sum of this 145 area, and assume this is it. In this case, one possibility is that maximum subarray sum should be the maximum suffix sum of Y plus maximum prefix sum of Z. It's possible. So let me write it down. Obviously, and it's possible that this, or this, or as I said, like this. So is there any case that I can create the maximum subarray sum for X in different ways? What do you mean? So this is the suffix sum of Y, this is of Z, and maximum suffix sum. So this is prefix. Yeah, I think this is the, I mean, I can't find maximum Subarray sum aside from these three ways. Yeah, I think so. So what I will return from each, recursive function should be this: maximum suffix sum and maximum prefix sum and maximum Subarray sum. Okay, so that being said, I'm still not sure if I can find maximum Subarray sum or maximum suffix sum, prefix sum in the constant time, but let's assume that it is possible. In that way, the time complexity should be n log n, assuming that there are n elements, because as is often the case in divide and conquer, I split this range into half and then half and half. 0 log n number of times, 0 log n height. Yeah, let's see that this is a kind of tree, and I can say 0 log n height levels. Yeah, because initially there are n numbers, and for each divide it becomes the half. Okay, and my another also I have a thing, how many codes there are in each level. It should be 1 and 2 and 4 and 8 and blah blah blah. So it should be and what I can say from here is that it should be 1, 2, 4, 2 to the power of log n. So this is it. Wait, is it real n log n? Let me quickly think. So this should be 1 times 2 times. Okay, sorry, let me do the complex analysis later. I'm not pretty sure even now. I don't know how many times it will take to calculate the maximum Subarray sum from the recursive function called results. So let me implement it first. Okay. So how do you call it? So the recursive function should be responsible for returning these three results. So let's say find. I make it very ambiguous intentionally because I have to find so many things. Okay, so this is the recursive function. And this is what I will return. Maybe I can pass nums to for the reference. Okay. So from here, I will implement the find method. Oh no. And I will return maximum Subarray sum maximum prefix sum and maximum suffix sum. And if I return this, so what I should return in the main method should be index 0. Okay, so I work on the implementation of find method. So firstly, I will think of the base case. This is it. Yeah, as I said, because I have to take at least one element, all of them should be num-sprawl. Okay, so now I will think of the not non-base case. So and I will divide the range into this and this. Okay. And I can say I will get Subarray sum, prefix sum, maximum sums. So I will make it super clear. Okay. So from here, I will return the tuple of firstly the maximum subarray sum, so this should be, as I said, this in line 31 to 34. This. Okay. But still, I have to think how I can get the maximum prefix sum. So for thinking of maximum prefix sum, I get the maximum prefix sum like this. Then I'm wondering if I should return this. Okay. So I will think of the maximum prefix sum in the same way. So the first possibility is that maximum prefix sum of y is that one. Or I think there is another case. So let's think something like this. This is the first range and the second range is like this. So the first case is like this. Sorry, yeah, first case is like this. So in this case, the maximum prefix sum of the first array should be 5, because I don't include 4, negative 4. But when I think of the maximum prefix sum of the whole, merged range, I should definitely include this negative 4 because I have more, numbers which pays off, or I should say which, with more than negative 4. So I think it's worth trying. I'm pretty sure it's worth trying, so that I should check sum of y plus maximum prefix sum of z. Yeah. So this is what I can say. And I will think there is another possibility somehow. Yeah. And one more case I can think is all the numbers are negative and I don't include it. In this case, I just have to take the maximum perfect sum of the range y, so it's okay. Okay, so I'm pretty sure this is the one. And maximum suffix sum, I can say the same thing. Maximum suffix sum of z, or sum of z plus maximum suffix sum of y. Yep, the same thing can be said. Okay. So that being said, I also have to return sum of the range. So I will return it. Okay. Then for maximum, and I have to return, max sum. So max sum should be the sum of this and this. No, sorry, not max sum, but just a sum. Okay, so maximum prefix sum, as I said. This. For this. Yes. Okay, so I finished my implementation. So I will come back to the complexity analysis. What I found so far is that each recursive function takes only the constant time, aside from the recursive function call of the child, call. So basically, in line 6 to line 14, each arrow takes the constant time. Yep. So I can say yep, this is n plus no, so 1 plus 2 plus blah 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 log n. I forgot where I wrote it here. So the time complexity should be Okay, I can say it in this way. Firstly, I get the sum of n, then n divided by 2, n divided by 4, and then finally n divided by, yeah, finally 1. So I can think, for example, if the original length is 16, the sum should be one plus 2 plus 4 plus 8 plus 16. Yeah. And what I can say is there is a kind of mathematics, and I will do some math, and I get this is actually the 2 times n. Yep, this is because this is n, and here I can create n, because let's think there is a box of, you know, there is a box, and for each time I fill in the half, and then half, and half, and half. So finally it reaches almost one box. So I can say this sum 1, 2, 4, 8 is 16. I mean, it reaches to 16. So that's why I can say it 2 times that. So that's the time complexity over n. For space complexity, I need the recursion stack only, so it should be log n. As I said, the height of this recursion call is log n. Or I should say maximum depth. Okay. So okay, so I will work through my code. Yeah. So let me go with a very simple example because yeah, I just want to cover all the lines in this implementation. I don't want to check everything. Yeah, like that, something like that. Okay, let me go with this. So in this case, I expect that the 3. Yeah. Definitely, I should choose all the elements as a subarray to get the maximum subarray sum. Okay, so that being said, let me think. So, okay, so here in line 68, the n is now 3, so I will call this one. Oh wait. So 0, 2, nums, and return 0. Okay. So, and I call the recursive function, and in the recursive function in line 975, still low is not high, 0 is not 2, so I go to line 78, and middle is now 1. So I do the recursive function with, oh, I found a mistake here. So set the find 0 to 1. This is about line 84. And also I will call the recursive function with 2 to 2. Okay. And for this, I still have to do the recursive function call. Yeah. But for this, line 67 one, because this is low is equal to high, in line 82, I return, yep, nums row tuple. So this is 5555. Okay. So here in line 66, the middle should be 0. Yeah. So now I'm talking about the self-defined code with 0, 1 nums argument. And in line 84, middle is now 0, and in line 86, I do the recursive function call. So it will be like this. And because here, for each of them, low is equal to high, so in line 84, I return nums row. So for line 67, because this is index 0, I return 1, 1, 1, 1. And for line 68, I return negative 3, negative 3, negative 3, negative 3. Okay, so now I will take a look, go back to, self-defined 0, 1 nums, line 65. So what I can say is now I've got 1, 1, 1, 1, negative 3, negative 3, yeah. So in line 97, this is 1, and this is negative 3. And this should be 1 minus 3. Yeah. So I get 1 here. Yep. Then in max prefix sum, this is 1. The sum should be 1. So this should be 1. Yep. With this, I will compare negative 3 and 1 minus negative 3. So this should be 1 minus plus negative 3. So this should be negative 2. So this is, and in line 99, I should return 1 minus 3 is negative 2. Okay. This is what I should return here. So I return 1, 1, negative 2, negative 2. Let me confirm. So in the range 0 to 1, max sub array sum should be definitely negative 2. Wait, oh no, obviously 1. And the second one, max prefix sum should be negative 2. No, 1, yes. And maximum suffix sum should be negative 2, yes. Total sum should be negative 2, good. Okay, and finally, I will call this line 63. So now I've got this. And this. No, 5, 5, 5, 5. This one. Okay, so I will calculate again. So max subarray sum 1 should be 1, and max subarray sum 2 should be 5, and max suffix sum plus 1, max suffix sum 1 should be negative 2, then max prefix sum 2 should be 5. So this should be 5. Okay. Sorry, I split 5 in this case. Yeah. And in line 95, max prefix sum 1 is 1. Sum 1 is negative 2. And max prefix sum 2 should be 5. So it should be minus 7, negative 7. Yep. And in line 97, max suffix sum 2 should be now 5. And max suffix sum 1 should be negative 2. And sum 2 should be 5. So this should be now 5. Okay. And in the end sum, this should be negative 2 and 5. This should be 3. Okay. So this is it. And I will return the first element 5. Yes, good. Oh, by the way, the second element, max prefix sum, should be 1, but now it is negative 7. Why is it? Oh, obviously this should be max, so this should be 1. Okay. Aside from that, everything looks good. Okay, so I submit my code. Perhaps you forget comma. Ah, yes, I forgot comma. Okay. Try again. Good, I submit my code. Okay, accepted, great. So, yep, I will quickly wrap up on today's coding session. So today I solved the question maximum subarray with divide and conquer. In this question, I'm given an integer array nums, and my task is to find the subarray with the largest sum and return that maximum sum. Yeah, and in the divide and conquer approach, I basically, in each recursive function, has this kind of range which is responsible for, and returns the maximum subarray sum, max prefix sum, max suffix sum, and total sum in that range. And with that information, the caller of the recursive function can build up the same information in the extended range, and it returns to the caller. Yeah, this is definitely the divide and conquer approach, and in the end, I can find the maximum subarray in the whole range. Yeah. Okay, the time complexity was n log n. No, I said n. Wait, is it correct? Let me quickly think again. So let me stop the video and confirm it. Yeah, so I couldn't confirm it completely, but I think the time complexity should be O of n. Yep, I recommend something if this is wrong in the description of this YouTube video. Yeah, but that being said, I finished my today's coding session. Thank you so much. Bye.